Assalamualaikum warahmatullahi wabarakatuh. I'm Cucuk Budiyanto from Universitas 11 Maret Surakarta. In this uh, second annual engineering and vocational education conference in 2020, I would like to share my research regarding the computational thinking skill development. This research is about the use of educational robotics in delivering STEM teaching. As a background story for this research, we noticed that STEM or science, technology, engineering, and math is considered as an important individual skills, and it is skills of choice for future career interests. Robotics hands-on activities also widely used in constructivism theory teaching, and because it is uh, acknowledged as one of the innovative learning improvement. In a hand, robotic enhance learners' high order thinking skills and abilities. On the other hand, robotics helps students to acquire problem solving skills. As our background in computational thinking ability, we underscore their CT is the method of solving problems that mostly applied in computational or computer science. While considering these two between CT and STEM, we notice that robotics are also largely advocated as a tool of delivery or tool of instruction in STEM learning. It is uh, a little bit question the research in the concerning about the correlation between STEM and computational thinking is largely underexplored. That's why we want to explore or investigate the correlation between these two in our research. Before I continue, I would like to emphasize that computational thinking skill is the ability to interpret or kind of analytical thinking that mostly used by computer scientists to understand behavior, and it is suggested by Wing that it has to be developed for the 21st century skill. The city itself consisted of five elements, which is the ability of abstraction, which is to separate the most important thing from the rest of the things that is not considered as important, and then generalization, and then algorithm thinking, and then modularity and decomposition. We will talk about it later when we discuss about the the application of city later in the next slides. The other theoretical foundation of our research is the understanding about the five E's of learning, which is the five phases of learning in constructivist approach, which is engagement, exploration, explanation, elaboration, and evaluations. While these five is a kind of sequence, they cannot be interchanged one another. So we expect that our research will contribute to knowledge and practice by highlighting the correlations or the similarity between STEM or STEAM in this regard with computational thinking indicators. It is suggested that robotic activities that adopted in STEM or STEAM teaching will uh, influence the computational thinking improvement of students as a byproduct while the activity is going on. To achieve our intention, we designed this research as a case study research approach and data collection conducted by interview and observations that involve 16 participants. We consider the 16 participants is quite sufficient because it is the exploratory paradigm, which is conceiving things. Even one participant will be enough to be explored. Our participants were purposefully sampled or nominated because they are pre-service teachers and they are also familiar with robotic courses, or at least they have taken robotics course previously. During the data collection, we video recorded the activities, and at some extent or some points under the participants' consent, we record them using tape or using mobile phone for further confirmation. This the activities in this research was conducted using computational thinking instructions framework that elaborated by Budiyanto at 2020, which is comprises 5 stages procedure to employ Lego Mindstorm EV3 while we were encouraging students to assembly and program the Lego robotics uh, in a set of activities. The activity itself consists of preparation stage, which is we get the students or the participants to be familiar with the situations of the research, and then we introduce the students to the activities in the project, including the instructions how to build the objects we want them to build, and the next one is assembling. We ask the participant to assembly according to the instructions and put or insert the program, and when the construction was finished, they will test the results. At the end of the activities, we give them time to reflect all of the activities they have done, including what they have learned during the activities before we close the project or the activities. Once the data were collected, we put we create codes and categories, and then we build indicators according to computational thinking and the 5 E's phases of learning, so that we can uh, map or we identify the themes that might be concluded from the analysis of the data. Upon the data analysis, we haven't conclude to the extent the findings still in preliminary stage, but at least we already identify that there is a correlation between abstraction and generalization at once with all of the phases of the STEM learning. It is quite acceptable because both abstraction and generalization itself is correlated to one another. Regarding the algorithm, uh, it was prominently indicated in exploration and explanation phase, while modularity mostly exhibits in elaboration stage, while decomposition mostly indicated in exploration stage. Upon this point, we found there were correlations between students' experience in the past with the way how they justify their understanding. Because, for example, one of the participants expressed that the object they have to build is similar with garbage truck they have seen previously in the film. So it is quite happy that they can express their idea according to their experience. Next one, we notify the use of educational robotics in the activities will encourage them or the participants to be actively learning because it is kind of hands-on media that they can touch, they can try, and they can see whether it is correct or not, or is there any fault is on the object they have built. Lastly, we notify the learning rates in steps by steps or scaffolding learning, which is learning gradually, mitigates the passive behavior of students during learning. For example, well, they use Lego robotics, which is consisted of small parts, robotics, and then they have to build one by one, brick by brick, makes them actively engage in the activities. So it was kind of mitigation for the passive behavior during journey. Okay, I think that's all from me. Thank you for your time, and I would like to receive your feedback. Thank you.